Section 8.2 is titled Factoring by GCF. Remember, that stands for Greatest Common Factor. And by the end of this lesson, we want to be able to factor polynomials by using the greatest common factor. Remember that when you are looking for the greatest common factor, we want to find the largest factor that's in common with all the terms as far as coefficients go, and then you want to find the lowest exponents that are in common with all the terms. So this is going to be similar to what we were doing in our previous lesson when we were factoring or finding the greatest common factor of monomials. So here we have a polynomial, actually a binomial, 4y cubed minus 16y to the fourth. And we want to factor this polynomial. So what we want to do is look across the two terms, and we want to find the greatest common factor. So essentially it is exactly what we were doing in our previous lesson, but now it's just strung together in polynomial form. So we have 4y cubed minus 16y to the fourth. So first we want to look at the 4 and the 16, and we want to determine what's the greatest common factor that we can factor out or pull out from those two terms. And hopefully you're saying that's a 4. 4 goes into 4 and 4 goes into 16. It's the largest number that goes into both. Now we want to look at the variable, and the same rule applies from yesterday. We want to take the lowest exponent that's in common in both terms. We have y cubed and y to the fourth. Essentially you might be thinking, what's the most that all of those terms can give? And it's always the lowest exponent. Well, the lowest exponent is a 3 on the y, so we're also going to factor out a y cubed. So our greatest common factor of these two monomials, 4y cubed and the minus 16y to the fourth, would be a 4y cubed. But what we need to rewrite now is what's left over inside, let's say a set of parentheses, if we put this in parentheses, if we factor this part out in front. So then we look at each term individually. If I factor a 4 away from a 4, I'm left with a 1. If I factor a y cubed away from a y cubed, I don't have any variable left here. So now my minus sign. I factored a 4 out of 16, and I'm left with 4. And I had y to the fourth, but I factored out a y cubed, so how many are left? You can simply subtract the exponents. I'm left with a y. Basically, factoring is the distributive property backwards. Now, if you were to redistribute the 4y cubed back through the parentheses, do you get your original answer? Well, 4y cubed times 1 is 4y cubed. 4y cubed times a negative 4y would be a negative 16y to the fourth, because remember, we add our exponents. And once we look at a few examples, this will start to make more sense. Now we have 6p plus 15p squared minus 9pq. So we want to factor out the greatest common factor, essentially factor the polynomial. So we have to look at 6, 15, and 9. The largest number that I can factor out of all of those is a 3. Then we look at the variables. We have p to the first, p squared, p to the first, and q to the first. And I'm going to go ahead and write the little exponents in just while we're working on this example. So remember again, it's the smallest or the lowest exponent that's in common. So they don't all have a q in common, so there's not going to be a q in our GCF, but they do all have a p in common, and the lowest exponent is a 1. I can't factor out a p squared from this term because these two, the first and last terms, don't have a p squared to give. They just have 1p. So now we need to rewrite everything that's left over inside the parentheses. So if I have a 6p but I factored out a 3p, I factored a 3 away from the 6, that left me with a 2. I factored the p out, so there aren't any p's left here. Now I have my plus sign. I factored a 3 away from 15, so I'm left with 5. I had a p squared, but I factored one of them out. That means I have 1 left inside. Now I have a negative 3, factoring a positive 3 away from a negative 9. Essentially it's division here. Negative 9 divided by that 3 I factored out is negative 3. I had a p, but I factored it out. but I also had a q that I didn't mess with, so that q has to stay in the back. What's nice about these examples is it is pretty easy to check your answer. You could always just redistribute the 3p back through, and do you get the original problem? You should. Again, notice it's division. 6 divided by 3 is 2, 15 divided by 3 is 5, negative 9 divided by 3 is negative 3. So that's how you get those coefficients. Let's look at another one. 8r to the 4th plus 17s to the 4th. So if we look at the 8 and the 17, we're trying to think of a number that divides into both of those evenly, or what's the greatest common factor. Well, 8 is divisible by 1, 2, 4, and 8. 17 isn't divisible by any of those numbers. So as far as the coefficient goes, the greatest common factor is just a 1. Now we look at r to the 4th and s to the 4th. Remember, it's the lowest exponent in common, but the variables have to be in common. The first term has r and the second term has s. So the GCF here is just a 1. When the greatest common factor is just a 1, this polynomial is already in factored form. It doesn't do us any good to factor a 1 out. Similar to division, it doesn't do us any good to divide something by 1. It's not going to change anything. So this is already in factored form. Okay, example 4, we have 6ab plus 3a. If you'd like to pause the video and try to factor some of these on your own. I know that factoring is probably a new concept for some of you, and it can be difficult or confusing at first. And again, what's important is that we continue to practice these examples. So we have 6ab plus 3a. 6 and 3, the greatest common factor there is a 3. I have ab and I have a. So how many or what variables can I factor out of the expression? Well, they both have an a in common, so I can factor out the a. They don't both have a b in common, so I can't factor out a b. So my greatest common factor is simply 3a. From the first term, if I factor a 3 away from the 6, I'm left with a 2. I factored the a out, but I have a b left over. In the second set, or the second term, I had a 3 and I factored a 3 away. I had an a, I also factored an a away. It looks like the whole term disappears, but remember that these are factors, so what times 3a is 3a? We have to have that placeholder of a 1 in the back. So the factored form of the polynomial is 3a times the quantity of 2b plus 1. Again, check your answer by redistributing back through. 3a times 2b, 3a times 1 should get you back to the original answer. A little more complicated here, we have a trinomial, 5x cubed plus 10x squared minus 20x. So we look at the coefficients, 5, 10, and negative 20. What's the greatest common factor? Hopefully you're saying 5. 5 is divisible or divides into all three numbers, and it's the largest one to do so. We have x cubed, x squared, and x to the first. So we want to take out the smallest exponent in common. That's going to be that x to the first. You can only factor out as many variables as each term has to give. So again, that back term, that negative 20x, only has one x to factor out, so we can't take out 2 or 3 that the first and second terms have. So now what's left over? If I factor a 5 away from 5, I'm just left with 1. I can write the 1 if I choose, but I don't have to unless it's the only piece left. But I'm going to have some variables here. Because I had an x cubed and I only factored one x out, I'm actually left with x squared. So you can see here how the 1 is not necessarily important because it's not a placeholder, because the x squared is there to hold its place. Then I factored 5 out of 10. That leaves me with 2. I had x squared and I factored out an x, so I have one x left over inside. And from negative 20 I factored out a 5, so that leaves me with negative 4 or minus 4. I had one x on that term, but I did factor it out, so I'm just left with minus 4 in the back. Example 6, 2x squared minus 3y squared. Again, you may be noticing that 2 and 3, the only greatest common factor between the two of them is a 1. And since I have x's and y's, nothing in common, my greatest common factor here is just a 1. And again, that doesn't do me any good. So this is already factored. Number 7, we have 20x to the 4th plus 12x cubed minus 8x. This is a good example for you to try on your own. So pause the video, try to figure out what the greatest common factor is between each of the three monomials, and then pull that out in front and rewrite what's left over. So if we're looking at 20, 12, and 8, the largest number that divides into all of those is a 4. We have x to the 4th, x cubed, and x. So the most x's I can factor out is just 1. Now what do we have left over? Well, 20 divided by 4, or 4 factored away from 20, is 5. We have x cubed left over inside since 1x was factored out, plus 3x squared. 4 factored away from 12 leaves us with a 3. And if I had 3 x's to begin with, I factored 1x out. I'm left with x squared. And with the minus 8x, I factored out a 4x, so that leaves me with a negative 2. The x that's back there got factored out, and 4 goes into negative 8, negative 2 times. Hopefully you got that one right. If you didn't, you can see where your mistake is. If not, make sure that you're asking questions in class. And I think this might be our last one. 2c to the 4th minus 4c cubed plus 6c squared. Again, pause the video here and try this one on your own. So I'm looking at 2, 4, and 6. The largest number that goes into all three of those evenly is 2. So the greatest common factor is a 2. We have c to the 4th, c cubed, and c squared. So again, it's the lowest exponent in common. They all have c's in common, and the smallest exponent is a 2. But now I need to rewrite what's left over. I factored a 2 away from a 2. I had c to the 4th, and I factored out a c squared. So I have a c squared left over. Because when I multiply this back, 2c squared times c squared needs to give me 2c to the 4th. I factored a 2 away from negative 4, so that's a negative 2. C squared I factored out from c cubed, so that leaves me with 1c in the middle term. I factored a 2 away from 6, that leaves me with a 3. I had the c squared, but I factored them all out, so that's what we're left with on the inside. Hopefully you're a little more comfortable with factoring the polynomials using the greatest common factor now by example 8. If not, make sure that you're asking questions in class. We will work on the first of 2 worksheets from section 8.2, so 8.2a.